how to calculate the reaction forces for the given problem. Okay, so now this is the box. Actually, we can say here there is a one beam, right? It's a simply supported beam, and on top here, this all actually is what is a uniform distribution of the load. Okay, here, and on top of it, there is a one point load here and point load here, and then here is there is a one point load is acting. So now for this case, we will see here how to find out the reaction forces at point A and B. Okay, so now here the reaction forces RA and RB we have to find out. So there is a 1 point force is acting, and here is also what is acting, and here is also what is acting. So all is a 5 kilonewton and 10 kilonewton, and it's a 5 kilonewton. And the uniform distribution load is a 3 kilonewton per meter. So now here each cell maybe we can consider to be as a 1 meter. So 1, 2, 3, 4 total is a 4 meter here. And this is the 1 meter. And here is what is a 1 meter. So now for this, how to find out the reaction forces of RA and RB? The first rule, the uniform distribution load must convert into a point load and should be placed in the middle of the beam. I mean the middle of the portion. So here 3 kilonewton per meter is distributed over the span of what? 4 meter here. So now the total is a 12 kilonewton which is acting here. Right, the same point. Here the same point, additionally 12 kilonewton is also what is acting. 110 kilonewton of point load is acting, and then now we converted this the distribution load and we placed over here. So the beam now looks like this. The middle here there is a 110 kilonewton. On top of it again what? One more 12 kilonewton. And here is actually is what? Is a 5 kilonewton. And here is also what? So 5 kilonewton. So now I have to find out the reaction forces A and B. So now here it is what is a RA, and this one supposed to be that is a RB here. Okay, so like this you have to first step you have to convert everything into the proper way. So now sigma of f of y, which is equal to be 0, then I assume that going up is what is a positive. So now RA plus RB, the first load, this one is going down, so minus 5 kilonewton, and this is also what is going down, minus 10 kilonewton, and this load is also what is going down, minus of 12 kilonewton, and another one more 5 kilonewton. I could say here 5 kilonewton. So 5 kilonewton, which is equal to be 0. So now RA plus RB, if I bring all these terms to be a right hand side, then I could just calculate 10 plus 5 plus 5, 20, plus 12, 32 kilonewton. So now I can just keep this as a equation number 1. So now this time take moment at point A. right? My assumption clockwise is positive because in the previous equation I have two unknowns. I want to make it one as 0, then I want to find out another one, so I'm taking a moment at point A, right? So if I take the point at moment A, the RA would become 0 because it won't I mean that it won't give any moment at the point, right? So here is a 1 meter, and here supposed to be as a 2 meter here, right? So 2 meter, right? And here supposed to be that is a 2 more meter, and here supposed to be here there is another. I mean, is my drawing right here? Okay, so the total 4 meters. So here's until is a 4 meters, and then here supposed to be here is a 1 meter. So the total span of the length is 6 meters here. All right, so clearly you have to write. Okay, so now take the first one, the 5 times of 1, 5 kilonewton into 1 meter kilonewton, which is going in the positive direction. So I take it as what, positive, and plus 10 times of, now becomes here what, 3, right? 3. So now 3 meter 10 kilonewton, then plus this one, now 2 plus 2 plus 2, so 5, total 5. So 5 times of 5 here, this is the kilonewton, and this is the meter, and minus of this 6 RB, which is equal to 0, because the RB which is moving in counterclockwise direction. So now is a 5 kilonewton meter plus 30 kilonewton meter plus 25 kilonewton meter, which is equal to 6 RB. So now this one 30, total is a 60 kilonewton meter, which is equal to 6 RB. So that RB which is equal to, right? So here actually is what, 6 meters, right? So the meter and meter could be cancelled, right? And then the RB which is equal to 60 divided by 6, supposed to be that is a 10 kilonewton. So one answer I found here, the RB is actually is what, 10 kilonewton. Now if you substitute here, then you could just find out here RA. So RA which is equal to 32 minus of 10, then actually is what, is a 22 kilonewton RA. So now I can just write down here is supposed to be that is a 22 kilonewton, and then this one supposed to be that is a 10 kilonewton. So this is how you have to calculate that your reaction forces, right, when they give combined with the point load and that uniform distribution. Okay, I hope that you all clearly understand that information, and I will continue